So now we're starting 5.5 guided practice, and the objective of this guided practice is to use the exterior angle theorem and the isosceles triangle theorems. We've not yet talked a lot about either of these theorems, and so we're going to start by defining what we mean by the exterior angle of a triangle. What we've talked about so far are like angles 1, 2, and 3. These are the interior angles of a triangle. But as you can see in this diagram, 5, 4, and 6 are the exterior angles of a triangle. So an exterior angle of a triangle is the angle between one side of a triangle and the extension of an adjacent side. Okay, so that is our definition. An exterior angle of a triangle is the angle between one side of a triangle and the extension of an adjacent side. So look, for example, at angle number 4. This is one of the sides of the triangle, the side that's between angles 1 and 3. And then an adjacent side would be the bottom of the triangle, and we extended it out to form the exterior angle. And we're going to now prove that given a triangle, such as the one over here in the diagram, the sum of the exterior angles, in this case the measure of angle 4 plus the measure of angle 5 plus the measure of angle 6, is equal to 360 degrees. And that this is true for any triangle. So let's start with the proof. And the statements are given, we just need to fill in the reasons. We have a triangle, which is given. Okay, and our first statement is that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. In other words, the sum of the angles, or the sum of the interior angles of a triangle, is equal to 180. We call that the triangle sum theorem. And we've already proved that, so we can use that as a theorem. Okay, so that's another statement we can use. Now, the next three statements all have the same reason. The measure of angle 1 plus the measure of angle 4 is 180. The measure of angle 2 plus the measure of angle 5 is 180. And the measure of angle 3 plus the measure of angle 6 is 180. And you'll notice those are all linear pairs. Okay, to be really precise about it, we probably should add another line to this proof before this and basically just indicate that angles 1 and 4 are linear pairs, angles 3 and 6 are a linear pair, and angles 2 and 5 are a linear pair, because the reason would be the definition of linear pair, right? It's a pair of angles that are adjacent and form a straight angle. That was sort of skipped, but it's pretty obvious, so we'll just assume it was stated. And then, now that we know that each of these pairs of angles is a linear pair, we also know that by the linear pair postulate, they are supplementary. And then by the definition of supplementary angles, they add up to 180. So a couple of steps were compressed into this. So we could say that we started with the definition of linear pair. Then we went on to the linear pair postulate. And then finally we ended with the definition of supplementary angles. In using those three back to back, we were able to say these are linear pairs, they're supplementary, and therefore their sums all equal to 180. That really should have been 3 lines instead of 1. But as long as you understand how it was done, that's all that really matters. The next line combines the equalities from step 3. Essentially, it adds the left sides of these 3 equations equal to the sum of the right side of each of these 3 equations. So we're adding 3 equations together. And that gives us on the left measure of angle 1 plus measure of angle 2 plus measure of angle 3, that part, plus measure of angle 4 plus measure of angle 5 plus measure of angle 6, this part, all forming on the left side of the equality. And then on the right, we've got 180 degrees added 3 times. And that's what we've got over here. So this was being done by the addition property of equality. Remember, we could take the shortcut. We're allowed to do that now. We could simply add up left sides of equations and right side of equations. And if we do so, we have another equation that's still true. So this equality, the measure of angle 1 plus 2 plus 3 plus 4 plus 5 plus 6 is equal to 180 times 3, which in the next line we see is the same thing as 540 degrees. You could just check that with a calculator. So let's see what's happening here. We now have pretty much the same statement, right? We just added 180 plus 180 plus 180. That's just using the addition. We just used addition. I might not have broken that out as an extra step, but if you see it as an extra step, you can just say addition. It's not the addition property of equality, though. Okay, so you need to make a distinguishing discrimination between something that is just doing addition versus something that's adding the same amount or the same quantity to both sides of an equation. That's not happening here, so this is just addition. The next step takes this part of the sum, measure of angle 1 plus measure of angle 2 plus measure of angle 3, and by using statement 2 above, it substitutes that part of the equality for 180. Okay, so now we are substituting 180 for the first 3 terms in this equality, but we leave the measure of angle 4 plus measure of angle 5 plus measure of angle 6 equal 540. So we're just using substitution here. And how do we get from 6 to 7? I hope you realize that we've subtracted 180 from both sides. So this 180 drops out, and 540 minus 180 is 360. So this has been done by using the subtraction property of equality. So we've subtracted 180 from both sides. So it's a subtraction property of equality. And that leaves us with what it was that we were to prove. That the sum of the exterior angles, measure of angle 4 plus measure of angle 5 plus measure of angle 6, is equal to 360 degrees. So a little bit lower here, we could complete our theorem. So this would be the exterior angle theorem. And it states that the sum of the measures of the exterior angles, one at each vertex, of a triangle is 360 degrees. Okay, so that is how the proof looks.